that many of you know, I'm Don Gordon. I'm the Executive Director of the Riley Institute. And it's a great pleasure to welcome all of you to the first night of Climate Change is Real, Now What? So tonight and tomorrow night's programs are the result of a partnership between the Riley Institute, the Schei Center for Sustainability, and the Institute for the Advancement of Community Health. Dr. Wes Dripps is the director of the Schei Center, which is named after Furman's 10th president, David Schei, and has been in operation since 2008. And Eli Hesterman, Dr. Eli Hesterman is the director of the Institute for the Advancement of Community Health, which is a partnership between the Greenville Health System and Furman University, and it was started in 2016. Eli and Wes have been great partners with us, and I really appreciate that so much. We're also grateful for the support of the A.J. Head Fund and the Bill Mayville Fund. General Bolden, who prefers to be called Charlie, we're so happy to have you. It's an honor to have you kick off this conference. And we also appreciate very much all of our speakers, Dana Beach, Allison Crimmins, Tony Bartolome, who have taken the time to be with us this evening. And we look forward to hearing from each of you. So at this time, I'd like to turn the program over to a longtime broadcast journalist, best known for his hosting of SCE-TV's The Big Picture and Big Picture on the Radio. Mark Quinn is an associate at the senior associate at the Riley Institute. Proud to call him my friend, Mark Quinn.
Thank you, Don. Appreciate your friendship. Appreciate being part of the Riley Institute that bears the Secretary's name, Dick Riley, who would love to be here tonight, but I can tell you he is enjoying himself on a beach in Jamaica right now. He sends his regards and is very excited about this conference, as am I. As we're all aware, climate change is an intensely controversial topic, at least in America anyway. In fact, we're often afraid to talk about it because we don't know what kind of response we're going to get from the listener. Well, we want to change that. We need to talk about this. We need to do it often. Tonight and tomorrow night, we move beyond the politics and controversies. We're going to look to the scientists. We're going to look to the explorers and the practitioners to tell us what they've discovered about our changing planet. Tonight, we'll hear the perspective of an astronaut who has orbited Earth 4 times. We'll hear from a scientist who has studied the impact of climate change on health extensively. We'll hear from a journalist whose deep dive approach paints a picture of impacts we see and causes we don't see, and a fierce advocate for protecting our natural spaces and habitats so future generations can enjoy them. I would say if you're here tonight, there's already a good chance that you believe climate change is real. You may be worried about what kind of world your children and grandchildren will live in. Or maybe you're somebody who's vaguely aware that climate change is a thing, but just not really thought about it a whole lot. I mean, after all, how bad can 1 degree warmer be? And what exactly is 400 parts per million? Over my head. Perhaps you're a student doing research in this area, or maybe you're just a student here to get some CLP credits. You know who you are, and it's okay. Maybe you aren't sure if you believe in this or not, and really don't care. But you really just wanted to hear from the former head of NASA. That too. Okay. So regardless of where you find yourself tonight, you're sure to discover something new over the next 2 nights because we've assembled a terrific group of speakers. We're going to begin tonight with a view from space. Major General Charles Frank Bolden Jr. was nominated by President Obama in 2009 and served as the 12th administrator of NASA. He led a nationwide NASA team to advance the missions and goals of the U.S. space program, supremely important to America. Among his numerous accomplishments as the head of NASA, Bolden led the agency in developing a Space Launch System rocket, an Orion spacecraft that will carry astronauts to deep space destinations, such as an asteroid, maybe one day Mars. He also established a new space technology mission directorate to develop cutting-edge technologies for the missions of tomorrow. Bolden has also supported NASA's contributions toward developing a cleaner, faster generation of airplanes. Under Mr. Bolden's leadership, NASA executed an unprecedented landing on Mars with the Curiosity rover. The launch of a spacecraft to Jupiter enhanced the nation's fleet of Earth-observing satellites and continue making progress toward the 2018 launch of the James Webb Space Telescope, the successor to the Hubble Space Telescope, which has unlocked millions of mysteries of the universe. Bolden's 34-year career with the Marine Corps also included 14 years as a member of NASA's astronaut office. After joining the office in 1980, he traveled to orbit 4 times aboard the space shuttle between 1986 and 1994. His flights included deployment of the Hubble Space Telescope and the first joint U.S.-Russian shuttle mission, which featured a cosmonaut as a member of his crew. He is also, maybe most importantly to some, a South Carolina native. What a life for Mr. Charles Bolden. Please welcome Mr. Major General Charles Bolden to the stage.
Simplify. All right. Okay. I think I've done everything right so far, so we'll find out here in a second. Let me join everybody in welcoming you tonight. And I will say one more thing. I actually hope there are at least some people here who have questions about whether or not it's a problem, whether the changing climate, and I've grown accustomed to not using the term climate change. I don't use global warming, I don't use climate change. I try to use a term that all of us can identify with, and I think I have found over the years that almost everyone, if people in Congress, if my colleagues in the Congress agree with me that the climate is changing, then that's a step in the right direction. So I haven't found too many people that don't say the climate is changing. And what I want to do in the next few minutes is just give you an opportunity to see what it is that NASA does from a global perspective to provide the data, just the information that helps us understand what we're up against. Is there really a problem? Because I've had an opportunity to talk to students here for 2 days now, and as I've told them in every class, if you don't bring your data with you, then don't come. It's kind of hard to convince somebody of something if you can't show them the metrics that make you believe what you do. So what I'm going to try to do here over the next, let me start at this view. Some of you are familiar with Cassini. Cassini is a satellite that just finished its, I want to say a 9-year mission to Saturn, doing incredible things, bringing us views like this of Saturn's rings. And last month, we finally flew it into the surface of Saturn and let it peacefully end its mission. But while it was there, it helped us to discover things that we won't talk about tonight, like the incredible moons of Saturn that we believe have an abundance of water that may harbor life. So that's a conversation for another night. But Cassini also allowed us to see this tiny little speck up here that I pointed to that's our home planet. So that's Earth from Cassini all the way from Saturn. If you look down in the insert, that's actually Earth with our own moon going around us. So we start from that perspective and come in. Some of you will recognize this because this is the view from Apollo 17. It's the beginning of when we started calling Earth the blue marble. Some of you who are old enough, and I recognize as I look through the crowd, there are not many of you, will remember Apollo 8. It was Apollo 8 that orbited the moon over Christmas Eve and actually brought us the first Earthrise from the moon. And in my mind, that's the beginning of the environmental movement because it's the first time that human beings had an opportunity to view our globe from the perspective of another heavenly body and see it in its beauty and grandeur that we just had not seen before. So this is just an example taken by the last crew to step on the moon, the Apollo 17 crew. This is an image that people have just had an opportunity to see this year and last. And it is the first time that you have an opportunity to see what we call the backside of the moon. Our moon moves around our Earth about once every 28 days, and that happens to be the same rate at which our Earth is rotating on its axis. So we on Earth, as the moon goes around us, we never get to see the other side. It also kind of revolves, but it's just the rates are such that they match, and we never see the backside of the moon except in this image. Discover is a satellite that sits 1 million miles away from Earth. We launched it for the National Oceanic and Atmospheric Administration, NOAA. And Discover it's actually a climate study satellite, giving us this great vantage point of our planet. And what you get is this view of the moon going around Earth. So just thought I'd add that in for a little color. The climate is changing. That's my premise. that I'm going to use to start the discussion for the evening. And I'm going to talk about three things that are significant about it. The first one is that it has profound implications. Any of you ever been to Venice? What's unique about Venice? And the students knew this. What is it? It's a city that just sits on canals and the like. That's not a canal, okay? That is Venice on a very bad day. It's like, and you're going to hear from Mayor Stoddard, I think, tomorrow night, and he's going to tell you, hopefully, a little bit about what South Miami would be like on a very bad day, and may actually be like some days because of the rising sea level. The seas are rising, it's a fact. The data says so, and this is what gives you a bad day. Sherry Goodman is going to talk to you tomorrow night, who is a dear friend of mine, but she's going to talk on the topic of the impacts of changing climate on national security. So I won't dwell on it. But imagine that you're a U.S. contingent of military trying to get somewhere to help somebody, and you thought you were going to get in your Humvee or in your ambulance or your other wheeled vehicle, and you're going to go pick somebody up. Hard day here. You're not going to make it. And so trafficability becomes a problem because of the rising sea level and other things that are causing us to really worry and wonder about how we move around. This is an area that is perhaps among the most photographed from space of anywhere in the world, the Aral Sea. And it kind of sits on the borders of Kazakhstan and Uzbekistan. It used to be a vibrant fishing area. Used to have fishing villages and everything around its shores. It was the fourth largest inland lake in the world. Over time, though, that you can see on the bottom, because the Soviets bottled off the two rivers that supply the Aral Sea, and the climate increasing in surface temperature, most of that water has now evaporated. The sea is what's left of it is mostly saline, so there is no fishing industry anymore. There is no life, there is anything. So it has had incredible societal impacts on that particular region. Here's Kilimanjaro. Some of you have heard people talk about the snows of Kilimanjaro. In 7 years, kind of what's left about it. So another opportunity. This is an image taken by a Terra satellite and several other different NASA satellites provided to NOAA, where it shows you, I want to do this without messing things up, okay. This is a big glacier, Larsen B, the Larsen B ice shelf, and that's where it was until January of 2002. But we know that as the climate is beginning, as the surface temperatures are beginning to increase, glaciers are melting at just radically fast speeds. And so what happened over about a 2-month period of time is that the Larsen B ice shelf, this glacier, became so, it melted at such a rate that all of a sudden it started just sliding down this way. And between January 31st, 2002 and March 5th, 2002, the ice shelf that was here is now here. So that's in Antarctica, and that happened over a period of 2 months, something that we would expect maybe to happen over a period of several hundred years. But that's what happened in 2002. The second thing about the changing climate is that it poses profound societal challenges to us. I showed you Venice on a very bad day. I told you Mayor Stoddard will hopefully talk a little bit about what we hope South Miami will not see very much, but they're not headed in a good direction. From the standpoint of societal needs, we could be in big trouble. If you look at these maps, they show you essentially 3 areas of the U.S., the Delta region down around the Gulf Coast, Florida, and then the northeastern U.S., which is, I live up in this area now. This is an area that today exists within a meter of the existing ocean surface. This is an area that exists within 3 meters of the ocean surface. So, and there are about 100 million people in these regions that I'm showing you. So this says these people are at risk because they live so close to major bodies of water that are being impacted by the rising sea level. The final thing that we want to talk a little bit about is we know that the climate is changing. We know that because the data says so. And it's really important for us to try to figure out what we can do. So NASA, their job is to try to provide the data. And the way that we do it, our approach, is to try to use spaceborne and airborne measurements. We fly missions every year in airplanes that go over the Arctic, over the Antarctic, and they take pictures and take other measurements. But we have a complete suite of satellites that are orbiting the planet continually. One of those suites is what we call the Global Precipitation Measurement Mission. It's a mission that we fly in conjunction with Japan's JAXA space agency. And this is a series of satellites that actually allow us to look at, say, a hurricane today or a typhoon and take a vertical slice of it. So we can look at the data that comes from GPM and we can tell the amount of rainfall. I mean, in terms of inches, that's going to fall on a particular area over a given period of time. It's really helped us with our weather forecasting. It's helped us with determining how we need to evacuate people and the like. It is a method that we're using to try to get people out of the way and save lives. It is not a way to save us from ourselves if we keep denying that the climate is changing and that we don't have an impact on it and we can't do anything about it. So, but it's a way of gathering the data. This is a whole series of satellites that are part of the system, and you can see the number of different nations that are cooperating with us. This is the French Space Agency, the Indian Space Research Organization, our own NOAA, JAXA is Japan, the Department of Defense, NOAA again, NASA and JAXA, a number of different folk. And here are the number of nations. This is not just what you're getting from the US or from NASA, but it's a conglomerate of nations that have reached the consensus that we're seeing things that are not really good for our environment. Earth is a really complex system. The thing that we look at most of the time is water. And how does water cycle in this grand scheme of things? It evaporates from the oceans, it goes into the air, and it condenses again, comes back down in the form of rain, snow, and ice, and the cycle continues. What's happening now is that as the Earth heats up, we're getting more and more evaporating from the oceans and lakes and the like. We're getting more and more rain, more and more violent storms, and which says, you know, the forecast for our future is not good unless we do something to try to control the temperature. There are a lot of different things that we do. We cooperate, as I mentioned, with NOAA when it comes to providing them data for weather forecasts, working with organizations like the U.S. Geological Survey to look at the interior and the surface of Earth, and then working with other organizations in the total system of Earth science, Earth system science, and trying to understand what's happening. When you ask, what does NASA use? What are the tools? These are the existing Earth science programs today. The ones that are up here in yellow, I guess that's yellow to me, are the ones that are scheduled to be launched. They're in formulation right now, and you can see the projected launch dates for them. We've got some of them down here that are already flying and giving us data. People have, let me give you one ray of hope, okay? It is a piece of optimism. Everybody worries about the present administration really killing NASA's Earth science program. As far as what we've seen, I happen to be the eternal optimist. Let me say that. And so far, what we've seen is if the present administration is successful in taking money out of NASA's Earth science program, you have to kind of look at this carefully, but we only lose those satellites. So still a lot in relative terms, but we still have the systems left that we have today, plus some that we have scheduled to go up. So not devastating, but not good. So I guess that's the lesson. This is new. We've been flying the International Space Station for 17 years now. So how many of you in the audience have kids or grandkids that are 17 years or younger? Okay. They have not taken a single breath, not one breath in their lifetime that human beings have not been living and working on the International Space Station 250 miles above Earth. Through every contingency that happens down here, through every crisis, through every dispute among the nations that are member nations of the International Space Station, there have always been human beings living and working in this environment. Another piece of very interesting trivia, there has always been at least one Russian and one American crew together working on the International Space Station. So we have an interesting perspective. When people come together with a common mission and a common goal, they tend to get along and they tend to work together. So when people ask me about working with Russia, I tell them we don't work with Russia, we work with Roscosmos, the Russian space agency. And so they're a little bit different than trying to work with the Russian government per se. So that's the reason we've been able to operate there. The missions that I have circled, though, when I became the NASA administrator in 2009, I asked the question, I said, hey, we've got the International Space Station that's orbiting Earth all the time. Can we put some Earth observing missions on there? Why would we want to do that? Well, the primary reason you want to do it is because it's cheap. To send the satellites that I've shown you before this, you've got to pay for a launch vehicle, you've got to pay to build the satellite, you've got to pay to maintain it while it's on orbit. The way we do it now is that we take these instruments, the sensors themselves that are the working part of a satellite, we put it on board another mission that's going to space for some other reason. Generally, it's carrying cargo to the International Space Station. We put the package in there that has the climate sensors. Either the crew or people on the ground robotically install the sensors and the instruments on the International Space Station. And so this is the abundance of Earth-observing missions that are now resident on the International Space Station. We didn't have that 10 years ago. And so, in fact, a number of these were launched over the course of, 3 of them were launched over the course of the year 2014. And I kind of coined the phrase that 2014 was the year of Earth, because NASA had an unprecedented 5 Earth science missions that we launched in that 1 year alone. And 3 of them ended up on the International Space Station. We use innovative ways in order to be able to better gather the data, to make it more meaningful to people. We either use, as an example, here, we have what we call the A-Train. It's a series of 17 different satellites from the US and our partner nations that are orbiting Earth kind of in trail of each other. So sometimes they're minutes apart, never more than a few minutes, because it only takes 90 minutes to go around Earth at the altitude where the A-Train happens to be. So they're just following each other, each giving specific types of data, but they go around Earth in the same orbit all the time. So that's one way to do it. You take a constellation of satellites that are bringing you a variety of data in something like the A-Train. So you get multiple sources of data that come to you over the same comparative period of time. Another way to do it is like we do, I mentioned the Global Precipitation Measurement System before. Here, we have a group of satellites or a constellation of satellites all getting the same type of data. So with GPM, we're looking for rainfall, snowfall, content of moisture that's coming from the clouds that eventually is going to get down to Earth. And what you do is you use it to form a comparative analysis from a multitude of instruments and sensors that are looking for the same type of data, so that you can verify or substantiate that what you're getting from one instrument is in fact true. So it kind of takes care of people who doubt, okay, who knows that satellite is accurate? When you have a whole constellation of satellites that are looking at the same time and they all tell you the same thing, then you can generally count on it. And then the third thing that we've done, and we did this for the first time this past year, this is called the Cygnus satellite system. They're actually what we call microsatellites. So I could take a Cygnus satellite and sit it in that chair. So that's how big one of them is. So when we launched the first Cygnus satellite system, it had 8 satellites in a package that we kicked out one at a time, so that they spread themselves in the same orbit, but they give us the same data, looking at the same kinds of things. Cygnus happens to be looking at cyclones, hurricanes, and the like, and again, measuring the intensity of rainfall through the vertical swath of a hurricane. So if a hurricane's getting ready to hit the southeast of the US, we can look at the amount of moisture that we expect to come from a particular part of the hurricane, make a forecast of how much rainfall we're going to have, help somebody like Mayor Stoddard decide whether he wants to evacuate the people of South Miami, because we can actually measure that a day prior to it actually making landfall, or 2 days prior to making landfall. So another tool that we have today. And then this unique, innovative way of putting sensors and instruments themselves on the International Space Station, where you don't have to fly them up to make them part of a separate constellation, but you put them on a fixed platform for a much reduced cost. People say, I think I mentioned to you before, we're really looking at water in all of these climate issues. How is the water circulating? How is it changing? How is the amount of water on Earth changing? So in this particular case, the GRACE family of spacecraft, they measure Earth's gravity. So they're two satellites in a GRACE family, and they're separated. They measured the distance between themselves very precisely, and one trails the other. As one goes over an area of land where, say, there is less water, like you fly over an aquifer in a place like West Texas. An aquifer is a collection of underground water, a reservoir underground, if you will. If there's water in the aquifer, then that's mass, and it gives you a higher level of gravity attraction. When the second satellite comes, it'll tell you whether or not there's a change, so you can actually watch as we empty or fill the aquifers over time. And this just is a sort of time-lapse photography taken with the GRACE measurement instrument. And as you can see, if yellowish or greenish is a normal state, you can see how it cycles over the course of a year at a time, how it goes from the aquifers filling and then emptying and filling and emptying. We use this globally, again, to look at how the climate, how temperatures on Earth are changing the amount of water in the aquifers. And in many cases, we use them to provide drinking water or other things for human sustenance. Remember I talked about the A-Train before. This is just sort of an example of some of the satellites in the A-Train and Cygnus and the other missions as they go around Earth. So some of them are giving us the same data. Some of us are giving us totally different, diverse types of data. That is the satellite, those are the various satellite constellations. What I'm going to now show you is, this is an example of GPM in its orbits of Earth. I'm going to add another satellite in that's going to give us, maybe it's measuring the gravitational difference, so it's giving us the level of water in aquifers. Another one may be measuring soil moisture, all kinds of things. And it ends up giving us a global picture of the climate, weather down here on Earth as it changes seasonally through the day and the like. And so another way that we do it. Here we're looking at, up at the top, what you're looking at is soil moisture as it changes over the course of about a quarter of the year. So you can see that actually the dynamics of the changing Earth are visible here, because at the top you're looking at moisture in the soil with, as it goes bluer and greener, it's probably a rainy season. And when it goes back to the yellowish, you're getting into the dry seasons and the like. Down here, the blue is actually showing you how the salinity of the oceans changes as you get more water taken from the oceans, the salinity level increases. You put water back into the oceans, and the salinity level decreases. Here, we put everything together that I just gave you, and you have a sort of an understanding of how we map the data that we feed to the people who are going to talk to you today and tomorrow in trying to help understand our climate. Hopefully I'll have an opportunity to answer some of your questions as we bring the panel back up, and hopefully for some of you who wonder how the heck we did it or what we bring you, we gave you a little bit more clarity on how the data is gathered with NASA. Thank you.
Fantastic stuff, General Bolden. We appreciate that. And for those, who wonder about the science, is the science settled? Is there enough science out there? I think the General can tell you, yes, there is ample science out there speaking about climate change. Just curious, anybody here in the audience has lived through what he was referring to, one of these extreme weather events, precipitation events, unlike the one they had in Harvey in Houston? 50 inches of rain. I will tell you, just a mile from my house 2 years ago on October, an extreme weather event in Columbia, South Carolina, a weather gauge 0.8 miles from my home recorded 17.2 inches of rain between midnight and 6:30 a.m. It was the most extreme precipitation event in the contiguous U.S. in over 20 years. So climate change came to my house in the form of an extreme weather event. And yes, we did flood, like many people in Columbia. It was a terrible event. And scientists tell us we'll see more and more of these extreme events as this goes on. Our next guest tonight is Tony Bartlemy. Let me tell you a little bit about Tony and the paper he works for, because the Post and Courier is so committed to original journalism and investigative journalism, unlike many other papers in the country which have abdicated that responsibility altogether, mostly in the name of cutbacks and money. But the Post and Courier is stuck with it, and a couple of years ago they were rewarded with the Pulitzer Prize. Tony's a special projects reporter for the paper. He's done excellent work examining the impacts of climate change along our coastal communities in his 4-part series, Every Other Breath: Hidden Stories of Climate Change. Tonight and tomorrow night, we're going to show you 3 very brief videos of highlights from the series, beginning tonight with a 1-minute video. And this is fascinating, even though perhaps on the surface it doesn't appear to be. Tony's reporting on the impact of changing climate as it relates to plankton. And let me tell you, no plankton, no marine life. It's that simple. Just like no bees, no food. His investigative work has won him the American Geophysical Union's Top Science Award. Let's watch now Every Other Breath: Hidden Stories of Climate Change.
So we all know that rainforests are important when it comes to climate change. But there's something out there that's a much bigger deal. Something tiny and beautiful. And it just helped fill your lungs with oxygen. We're talking about plankton. Yeah, those tiny critters in the sea. Most people don't realize this, but plankton produce half of the oxygen on Earth. That's every other breath. But there's a problem. The climate is changing, and so is the plankton. In South Carolina, we're finding lower levels of zooplankton, the foundation of the food web. And a rapidly warming ocean could threaten the open ocean's phytoplankton. The tiny and beautiful and mysterious stuff that gives us every other breath.
That is the kind of work that moves the needle on this conversation. Short, to the point, but it makes you think, doesn't it? Please help me welcome to the stage Tony Bartlemy from the Post and Courier.
So it's great to be here in Greenville. I got my first journalism job in Greenville 30 years ago. It's really nice to be back. Love the city. So when I do an in-depth report, I shoot for something. It's a 3-letter word, and that word is aha. It's a great word, right? It's so short, just 3 letters, but it means so much. It means an awakening to something new, right? There's kind of a sense of relief in it, right? Ah, and then ha, like yeah, of course. So it implies a deep sense of knowingness to something. And I've had lots of aha moments doing this climate change series. First aha moment I had was with when I had a conversation with a guy named Dennis Allen. And Dennis is the director of the Baruch Institute down in Georgetown. Great guy, kind of looks like Santa. Big gray beard, really just radiates goodwill. And he's been measuring zooplankton for 35 years or so. And he's been doing it week after week using the same methods. And this is incredibly important because doing this gives you an idea of how things have changed over time. And so in an understated way that Dennis Allen, the way he talks, he says, Tony, by the way, we've had a 40% decline in zooplankton here over these years. So he's really laid back, but I'm saying 40% drop. That's a 40% drop in the first link in the food chain. So I run back to the newsrooms, do a little more research, and then I learn a little bit more about plankton. Plankton is basically stuff that floats in the ocean. You've got the zooplankton, the insects of the sea, and then the phytoplankton are kind of the plants of the sea, the grasslands of the sea. So I go to my boss. I say, "Hey, I've got this great story. There's, it affects everybody on Earth, or hardly anybody's talking about it, and it's about plankton." And oh, by the way, I need to go to Bermuda and Hawaii. So I explain, Dennis has been measuring zooplankton, but the only other places that have been measuring the phytoplankton are in Bermuda and Hawaii. He says, "Tony, why are you so excited about phytoplankton?" And I said, "Well, that's because they produce half of the oxygen on Earth, or every other breath." So we did that. We used that as a launch, kind of a launch pad to do several other in-depth stories about climate change that had kind of been ignored. And fading coral reef or bleaching coral reefs, huge underwater disaster taking place below the waves. And then we did something really cool. Just really briefly, we got this camera from a defense contractor, the only camera of its kind in the country, and it can see CO2, which is invisible. So we went around town, took pictures of smokestacks and cars, and I had another aha moment as I was doing this. We are literally surrounded by fires. In our cars, when we turn on a light, that's a fire, but they're invisible. We've done a great job of cloaking combustion. So thank you for this opportunity to share my aha moments, and really it's been a privilege to share these things with our readers. So thank you very much.
Tony, we look forward to hearing more from you in the discussion. Seriously, doing tremendous, great work with the Post and Courier, so we salute you in all you do. We're now privileged to hear from an environmental scientist who has been at the EPA since 2011. Allison Crimmins was the lead author of the U.S. Global Change Research Program's assessment on climate change as it relates to human health. A specialist in climate change risk and impacts, her research is focused on the impact of climate change on health and also the economic benefits of global mitigation of climate change to the United States. She's going to come and share with us now some of what she's learned in her research and the impact of a changing climate as it relates to your health, as it relates to the health of your children and your grandchildren. Please help me welcome Miss Allison Crimmins.
Thank you. It's very good to be here. I would like to ask you to zoom in from space. Come on a little Neil deGrasse Tyson journey with me. Zoom in from space, zoom in from the ocean, zoom into the US, into this state, into this room, and into yourself. And ask yourself how climate change affects me. This is an important enough question that 8 federal agencies got together, which is a success in itself, to assess the body of literature that's out there on how climate change affects human health in the United States. And we looked across this broad range of literature to put out this assessment. It came out last spring. So let me see if I can. So I'm going to share with you 3 of the top findings from this assessment. And I'll go a little bit more in depth into the second one, and I had a bunch of sweet tea, so I'll talk really fast in that one. So this first bullet point seems very obvious, that climate change is a significant threat to the health of the American people. This should be an easy statement to make, but sometimes it's not. And I want to point out some very specific elements of this sentence that made it so important for us to state in this report. And the first one is the word is. It's not climate change will be. Climate change is a significant threat. This is already happening here in the United States, which leads me to the next part, to the American people. This is not happening to someone far off in another land. This is happening to us right here, right now. So that's why this is one of our top messages of this report, even though it seems like a simple message. The second point is that we found in our work that climate change exacerbates existing public health threats, but also creates new public health threats. So I'm going to take you through just a series of examples. I'll give you 3 examples where it's exacerbating an existing public health threat, and 3 or 4 examples where to show what I mean by creating a new public health challenge. And so this is the part I'm going to move quickly through and just give you a little flavor of some of the impacts that we found in this report. This first one is a heat-related illness and death, which is something that comes to mind for a lot of people when asked to think about the impacts of climate change on human health. They often think of heat waves. We looked at both heat and cold. And so this graph on the right is looking at projections of heat-related deaths in the red and cold-related deaths in the blue. And you can see that with a warming world, we expect an increase in heat-related deaths and a decrease in cold-related deaths. But that increase in heat-related deaths outweighs that decrease in cold-related deaths, such that by the end of the century, we were projecting tens of thousands, an increase of thousands to tens of thousands of premature deaths every year because of climate change. The second chapter is on air quality, and we looked at outdoor air quality, indoor air quality, and aeroallergens, like ragweed pollen. I'm showing you a picture here on wildfire, which was definitely in the news a lot this year. And this is a great example of how climate change exacerbates existing health threats. We know that wildfires happen. They've happened for forever. But climate change is making them more frequent and more severe. And this has a lot of implications for human health for the people who live there, but also because smoke can travel so far away from wildfires, it has a lot of cardiovascular and respiratory implications for people who live very far downwind from where these wildfires occur. The third point, the third chapter is on extreme weather events, and our chapter looked at extreme precipitation, flooding, hurricanes, droughts, wildfires, winter precipitation. I'm showing you a map here of flooding impacts from hurricanes. This is a composite map of over 31 years put together because I wanted to point out that I'm from the Midwest originally, and so it's easy to think, oh, hurricanes, that's not my problem. That's a coastal thing. But the impacts of flooding from events like hurricanes can be seen really far inland. And so this is not just a coastal problem. I'm going to move a little bit more to what I was talking about in terms of climate change affecting or creating new public health challenges. We had a chapter on vector-borne disease, which looked primarily at West Nile virus and Lyme disease as an example of a tick-borne and a mosquito-borne disease. I'm showing you maps here of Lyme disease cases in 2001 and 2014, and you can see that these cases are spreading into new areas. So it's not that Lyme disease is a new disease, but this disease is occurring in new parts of the country where it wasn't before. So a doctor or a nurse or a public health official in a state where this was not a problem before now has to consider Lyme disease and make their patients and constituents aware that this is a problem in a new area where we haven't seen it before. Along that same line, we looked at waterborne diseases, and this is an example of harmful algal bloom in Puget Sound. And it's an example of a public health threat occurring in a new time. So these can happen in new places. They can also happen in new times. If you can squint up here and see these dots, the black dots are the baseline years, and the blue dots are projections going out into the future, so that the dark blue is in 2095. So if you just looked at April, and you looked at where the baseline year is in April, that black dot, you can see that we're now seeing those same levels projected into the future. We will see those same levels as early as February. So thinking about this in terms of your recreational waters or eating shellfish, those sorts of exposure to waterborne illnesses, we're going to see those occurring in new places, but also in new times of the year where they haven't been a threat before. I put this one in here because I think it's a really interesting result that we came out of our food safety chapter. The impacts of climate change can affect the pathogens on your food and the distribution of our food system and our food security. But one impact that a lot of people had never heard of before was that climate change and rising CO2 can actually affect the nutrition of your food. It affects the protein to carbohydrate ratio of a lot of crops like wheat and soybeans. It can also lower the micronutrients of that food. So in other words, the piece of bread you're eating today is more nutritious than the piece of bread you're going to be eating in 2050. Or if you're old enough to remember those old cereal commercials, you know, it's like you have to eat 7 bowls of Raisin Bran to equal 1 bowl of Total or whatever it was. So this is a really important impact in countries where protein deficiencies are a problem. They're not getting as much protein or as much micronutrients. It's also a problem in the US, for example, where we have obesity issues, where you're now getting more carbohydrate to protein ratio. And then I have to end here on, mental health impacts. In my examples of climate impacts on health, I wanted to end on mental health impacts. Everything that I have just said has a mental health impact. All of the examples I gave you before all have mental health impacts associated with them. In addition, we see a lot of mental health impacts coming after extreme weather events and disasters, of course. We also have mental health effects just from hearing about climate change on the TV or seeing it on the TV every day. And there's impacts on people who have existing mental health conditions. For instance, some people who are taking medications for mental health illnesses have trouble thermoregulating their own body, and so they're more subject to extreme heat days. So this was a really important point to put in here, and it kind of crosses across all the other topical areas. And it's a hard one to actually quantify, but a really important thing to remember. And I just, I kind of siloed these into heat and air quality and vector and water and food, but of course that's not how a real person would interact with all of these things. You could be having a bad air day at the same time there's a heat wave that causes a power outage, and you can see some of these cascading failures that can have health impacts all the way along the chain. So the last point I wanted to make from the assessment's finding is that every American is vulnerable to the health effects of climate change. And we looked at 8 different populations of concern or vulnerable populations. And though everyone is subject to climate impacts on health, these groups were particularly vulnerable. But one thing I wanted to point out about these groups is once you start looking through there and maybe looking for yourself in there, we were all children at one point. We all hope to be older adults. I showed you impacts on the coast. There's, impacts inland. There's impacts because of your job if you're working outside, or if you're a tribal member, or if you have a pre-existing medical condition. And if you don't fall into one of these categories, at some point of your life, you probably have a lot of loved ones who do. And so this kind of gets back to my original point, that this is not a problem that's happening far away to someone else. This isn't polar bears and glaciers. This is happening right here to us, to the people in this room, right now. And so with that, I will hand it over.
Okay, one person we did not hear from during the presentation is the man in the middle. That's Mr. Dana Beach, who's the founder of the Coastal Conservation League in Charleston. I dare say probably one of the most influential environmental organizations, not just in the South, but perhaps maybe in the country. So Dana, we are delighted that you have joined us here tonight. Thank you very much. Allison, let me start with you. A question about the impacts on health. That's one thing, but there are also impacts on the economy. There are some people who would argue that climate change is hard to re-engineer because if we live in a carbon-constrained world, that means trouble for the economy. It could be too expensive, right? But the other side says, if we don't address this issue, there are impacts on your wallet. If you get the attention of people in their household budget, they tend to pay attention. What are we talking about here?
There we go. That's an excellent question. I think it's a really another element that brings the subject of climate change to what an individual cares about. It makes it more relevant to all of our lives when we're thinking about how climate change affects me. And so there's a lot of work going on right now to quantify the impacts of climate change in a scenario where we do something and in a scenario where we don't do something. And everything that I just talked about in terms of health impacts, of course, have economic impacts from those health outcomes, but also to our healthcare system. But there's a lot of, I guess I should also say, of course, extreme weather events have huge economic impacts, and those are very visible to us. A little less visible are some of the economic impacts on things like our infrastructure. So extreme heat can affect rails and make trains run slower. They can affect our roads, our bridges, our buildings. They can slow or delay airplanes. There's a lot of impacts to our ecosystems that's just a lot harder to quantify and put a dollar sign on, which doesn't mean it doesn't have a value, but it's difficult to put it in a cost budget analysis. And so I guess I would point the audience to the fourth National Climate Assessment. I'm not sure if you're aware of this document, but it's the U.S. Global Change Research Program is congressionally mandated to put out an assessment of impacts of climate change on the United States on a regular cycle. And the fourth assessment was just released on Friday for public comment. So it's the draft version is out for public comment. And so it's also an opportunity to be engaged with your government and to look at this document. Anyone can review it in the world, and you can say, I want more information on this, or this wasn't clear to me. And there's a lot of good economic data that is in this fourth National Climate Assessment that we haven't seen in the ones before.
This is a compelling document, and one that is so comprehensive and so difficult to read in some spots that you can be overwhelmed. And that's one of the issues that I know Dana deals with, trying to delineate some of this information and make it palatable for the public to consume. Because some of what Allison is talking about is difficult science. It's tough. But it's your job to get people engaged in. And how hard is that to do in your job?
Well, I'm not usually the person on the panel that brings the good news, but Allison has said very compellingly that we are facing the impacts of climate change today. They're not something in the future. They're not something somewhere else in the world. They are here today, and I would like to add to that we also have the resources and the technology today to deal with the problems and to mitigate greenhouse gas emissions without new scientific breakthroughs. It exists today, and actually it is financially, not only is it achievable, it is less expensive than fossil fuel-based sources of energy. Just the most recent report from Lazard, which is an international consulting group, basically concluded that today solar power can be produced less expensively than the cheapest fossil fuel-based power source, which is natural gas, about a penny less per kilowatt hour.
4 cents.
4 cents, right. And actually solar is even dipped below 4 cents now. So the way to frame it, I think, is this. To me, there's sort of three components to this question, and Mark, get your question to me. There's technology, which is pretty easy to understand. There's psychology, which is a little bit harder to understand, and that's our big challenge. And then there's politics, and those two interrelate. We now know a lot about climate science, but we know now over the last 20 years we've begun to learn a lot more about how we think as a species. And we've discovered that we are subject, instead of the sort of popular characterization that many of us have learned in economics, that we're rational actors, that we subscribe to what is called standard utility theory, that we make the right decisions based on a clear-eyed analysis of the facts, that we are rife with decision biases. We consistently make the wrong decisions, predictably wrong, based on our mental architecture.
Well, humans are hardwired for fight or flight, immediate danger. Not so much a danger way, way, way down the road.
Right, but when we look at things that seem to be unfolding in a fairly slow pace, which climate change appears to be, we do things like discount future impacts, heavily discount them, and we discount them, literally discount them both financially but also intellectually. We discount the potential danger that they represent. The problem with that is that if we only face these decision biases, we could probably correct those over time with education and evidence. As the general said, evidence is what it's all about. But we also have, pushing against that, a very well-organized, well-funded effort on behalf of the fossil fuel industry to make sure that we remain confused. And you'll hear tomorrow night Bob Inglis, who has helped produce a movie called Merchants of Doubt. And in that movie, you would learn that the same people, literally the same individuals who were involved
Big tobacco.
in the tobacco fraud, are also involved in the confusion about climate. The points that have been made, well, we don't know, as our head of the EPA has said, it's too difficult to understand, to be able to predict.
The science
what's gonna
isn't
happen.
settled, right?
It's not too difficult. It's difficult if we are intentionally confused by a very well-funded and vested interest. And so what we've said, we've concluded as an organization, is that we don't talk about climate change. We talk about things like energy independence, about clean air, about competitiveness. And the additional piece of good news I would add is that in South Carolina, even, we tend to be more resistant to change than some states, and a little bit less rational than some states. Y'all know the James Lewis pedigree. We're too small to be an independent republic and too large to be an insane asylum. That's still true. But we have been able to pass one of the better solar laws in the country 2 years ago. We removed the prohibition of third-party leasing of solar facilities. The result of that law is that solar deployment has increased 40-fold in South Carolina in just a couple of years. So the solar industry is here in force. The power of the market. I mean, I, as an environmentalist, who ever thought I'd be advocating the power of the market? But the power of the market is at work here solving climate problems. And if we simply take that and extend it and make sure that we can go as far as we should be going with respect to greenhouse gas emissions, we don't have to stop burning all fossil fuels. We just have to stop burning most of the fossil fuels that we're burning. There is a transition path, and so it is not a hopeless situation. That's what people need to understand.
Right.
We can change the future, and the technology to do it is here today. We need to simply overcome the psychology and overcome the special interest.
That public policy piece that you mentioned, that bill that passed 2 years ago, was one of only 2 bills in that session that received no nays from either the House and the Senate. Passed unanimously, signed by the governor, and it was the result of work between many different organizations in the state. And that's what it takes. We're talking about cooperation between utilities, conservationists, and people on the ground, advocates who were asking for solar energy. Tony, I want to ask you, Hurricane Irma blew through Florida not long ago, but the effects on Charleston were pretty dramatic. The center of circulation of the storm almost 350 miles away, down near Orlando, Florida. And yet on the Charleston Battery, they saw the second highest storm surge ever recorded, second only to Hurricane Hugo in 1989. And if you're from South Carolina, you know the legend of Hurricane Hugo. It was a devastating, awful storm that wreaked tremendous amount of havoc. But that day on the Battery, I think some people came to the conclusion that climate change had come directly to Charleston. It had showed its face before, but that was a very dramatic scene.
It was a huge event. I live in downtown Charleston. The water outside my front steps, up to here. So these climate change stories. Climate change is very, very challenging to talk about because it's so nuanced. And how many of you wake up in the morning and say, I'm going to pick up that newspaper, I'm going to go online and read the most nuanced story I can find, with a bunch of caveats, and it happens in the future. I mean, it's a big challenge to talk about. And I think Mark alluded to this, how our brains are kind of wired. Our brains literally are wired to respond to immediate, direct threats. We see a snake, our amygdala just lights up and we get out of the way. When we think about the future, our brains process things differently. And because of that, we begin to incorporate our own bias, our own preconceptions into that sort of future scenario that's being talked about. So when I write a story, anybody writes a story about climate change being in the future, it's competing with people's beliefs and preconceptions. And if those are deeply ingrained, as they seem to be in a lot of people, we lose. So you've got that. And then finally, you've got this sort of sense of helplessness that when you see these huge events happen. And that's a huge thing to try to overcome. I think there are some ways to do that. We maybe could talk about that a little later. But it's getting through to that, overcoming that sense of helplessness is really the key to getting the energy to take action, I think.
Curious to know, Tony, the response from your readership about your series.
It was
broadly speaking.
So I wrote about plankton. It was huge. People were, talked about it to all across the country. Surprised me. So people are interested. It's just how you tell it. So I didn't write this story to try to scare people. I started off the story about the plankton with a World War II anecdote. You got to do that. You got to try different creative techniques to draw people in. And then once you have them interested, then you can kind of.
What was that anecdote?
So back in World War II, right, the sea was a battleground, right? And, whichever side mastered the sea's terrain would have an upper end, right? But the sonar operators back then were seeing something weird under the water, under the waves. They were seeing, at night, it was as if the bottom of the floor, seabed, would rise, and then it would sink in the morning. So this is, if you're on a submarine, you want to know what's going on. You want to know where the bottom of the ocean is. So they started investigating, and by the end of World War II, they still they had no idea what was going on. But over time, science takes time to figure out what's going on. They realized that it was a massive migration of plankton. And what happens is the plankton rises to the top of the ocean and feeds on other types of plankton, and then descends to get away from predators. So that was a totally random way of getting into a story.
General Bolden, let me ask you a question about leadership, because if a country is going to confront something as big as this issue, leadership has to start at the top. The Paris Climate Accords were signed not long ago, several years ago. The United States now is the only country in the world. Syria just this last week signed the Paris Climate Accord. Syria. To which you say, seriously, really, United States stands alone now as the only country. We have an administrator at the EPA who denies climate change, who is extracting climate change information from the websites. We have a president who said, the science is not settled. Where will the leadership come from on this particular subject?
It's been a topic we've talked about. I've been here 2 days now with the students, and that's a question they always ask. What can they do? This is, I said I'm the eternal optimist. I think number one thing they can do is vote. So the leadership actually starts in this room, and you only need to look at the results from a number of the elections yesterday to know that sometimes we surprise people with our thinking and our reaction to situations that we believe are untenable. So I think individuals can take a role by voting and putting in people who share their concerns about the changing climate and the fact that we can do something, people who want to take action. The second thing from people like me is to take on, when I was the NASA administrator, is to make sure that I become the voice, the face and the voice of an agency that provides the data, not just to the American public, but to the world. Is another thing I was able to share with the students today is that, like it or not, everybody looks to the U.S. for leadership. Everything abhors a vacuum. When there is a lack of leadership, things drift in to take that over. The leaders in the world in the issue of climate are about to become the Chinese, and they're serious. They are moving toward all electric vehicles, and they have set, I think, a 25-year goal to actually have no fossil-fueled vehicles anymore, but all electric vehicles. It's a matter of necessity, and it's because they're finding that if they don't do something about the climate, there will be an uprising. You know, the environmental situation in China is so
It's desperate.
severe today that if you go to the U.S. Embassy in Beijing, the kids that live there, the sons and daughters of U.S. employees in the embassy, their football fields are now under domes because most days the weather outside, the climate is just it's just too toxic for them to exist. So they've had to construct domes. When you talk about cost of living in our current environment, at NASA we take a look. We actually use our own data. And the chart that I showed you of the areas of the Florida coastal regions that are within 1 meter of the ocean surface today, 3 meters as you go farther inland, it impacts where we put launch pads, launch facilities. It does us no good to be the leaders in space exploration if we don't have a launch facility from which we can launch. We launch out of a place called Wallops on the eastern shore of Virginia. We're about to the point where we can no longer we're probably a decade away from not being able to use the present launch complex where we launch orbital ATK on their cargo missions to the International Space Station, because you can, as the mayor will probably talk about tomorrow, you can keep building seawalls and keep shoring up the beach, but it's just gradually eroding away, and after a while there's not going to be substantial base for us to have a launch facility. So we're going to have to move them farther and farther inland. So there are definite negative financial impacts to trying to ignore the problem instead of dealing with it. But now that just talks about dealing with something that is existing. We've got the question that I don't have an answer to is, how do we become proactive so that we at least arrest the changes that are occurring today, keep the temperature from increasing by fractions of degrees each year, because if we don't do that, then we're just throwing away good money after bad, because all you're doing is trying to slow the deterioration of our environment. We've got to reverse the rise in temperature. We've got to reverse the rise in sea level, and that requires action on the part of all of us. So I get back to my first thing. You got to vote. You've really got to tell people, what you will and will not tolerate. An example I gave to the kids today is, if I talked to a young lady who wants to work in sports marketing. I said, let me give you an example. You become a sports marketer and you're working for Cam Newton. How long do you think he's going to let you get away with bringing in no endorsements for him? She said, probably not very long. I look at members of Congress as my marketing manager. How long do I let them get away with bringing us no results to a known problem of increasing temperature, increasing sea level rise with no results? You fire them,
Interesting point. Dana?
The good news, again, is that this global problem is sort of paradoxically as been addressed locally better than almost anything I'd been involved with. And especially during the debate earlier about drilling, offshore drilling off the coast of Virginia, South Carolina, North Carolina, and Florida. And I think most of you probably know that every single coastal town and city passed a resolution against offshore drilling. This is in the former administration, Obama administration, and the proposal was withdrawn. And that was not only the result of those cities and towns, but there were citizens groups that formed up and down the coast. And these were literally people who had other jobs, people who were retired, and students who got together and started groups like SODA, Stop Offshore Drilling Association in Pawleys Island. There were people on Isle of Palms, and they made an enormous difference. They changed the future. Now we're back again with offshore again, but this stuff never ends, really. I mean, this is what advocacy and really citizenship is all about. But the main point is that they were successful. We all were successful, and we can be successful again under this new regime. The other thing on the other end of the spectrum, I guess, on the subject of leadership is corporate leadership. And in some ways, ironic, maybe not, some of the biggest corporations in America have made commitments to zero waste and to net carbon neutrality. So they are leading. The U.S. government is hanging back. The administration certainly is hanging back. But they're leading for a number of reasons. One is some of the leaders of those companies are great morally directed people, which is wonderful, but they also are selling to consumers who are insisting on responsibility, corporate responsibility. So there are so many ways that leadership can manifest itself, and in all of these ways, it has transformed the debate.
Yes, because I can tell you when companies look at South Carolina now, looking to come to do business here in the state, one of their biggest costs typically if you're in manufacturing is going to be electricity. And one of the first things they are going to ask you when they're scouting a site, when they're looking at potential places is, how much renewable energy can you provide for me? And that's important to them. It's part of their corporate culture. It's part of answering to shareholders who are demanding that. And if your job is to deliver power to those people, you have to find ways to deliver clean power. So it is starting with the corporations. It's starting in boardrooms. It is starting with those citizens groups because they have the power to talk to the people. Let me ask you, Allison, I'm curious about, we've talked an awful lot about the science and is the science settled. I've seen where the Prime Minister of Canada said she believes in both sides of the science. I'm not sure what exactly she means by that. Perhaps you could decode a little bit. Is there two sides to the science that we should know about in this particular argument?
No. We are very lucky that physics is not driven by politics, and so we all have our dark moments nowadays, but I think that's something that we can all remember, that at least the science is not driven by the politics, and that will shine through. I agree with both Charlie and Dana about these. There's hope, there's action. I wanted to add to that list that I get asked a lot, what's the one thing that I can do about climate change, and my response is to talk about it. And it may seem like a very simple thing to do, but I mentioned I'm from the Midwest. It's not exactly a polite conversation around the dinner table at Thanksgiving necessarily, but I encourage you to have those courageous conversations with people. This is not a political issue. This is science, and if we talked about it later this month at Thanksgiving, if we talked about it with our neighbors, if we talked about it with our friends, if we asked questions, it would just become part of our normal conversation, kind of like the weather is. And I think normalizing this conversation is a huge action. And if you think it's small, just think about the fact that it is a lot of small actions that caused the problem in the first place. And so I think it's a lot of those small, courageous conversations that can solve the problem.
Well, Tony, let me ask you, because one of the important things that your job entails is taking information from people like Allison, taking information from that report that was just released last week, a huge volume of information, and somehow decoding that and making it presentable for your readership or for your viewership in this particular case. How difficult is it to tackle a subject like this, strip away the science and talk like a normal person?
It's super hard. You know, actually, I discovered something just the other day. I found this app that allows you to that it takes a piece of writing and rates its reading level, and and so I thought,
Okay.
so what do my stories look like? So I went back and I looked at some of the stories that I did when I was younger, and they weren't so good, and they were at a 12th grade level. I thought, oh, wow, that's pretty awesome. Smart. I looked at some of my more recent stories that I thought really worked, 6th grade. Yeah, or even there was one 4th grade story. And so you've got to, that's not necessarily less sophisticated writing, it's clearer.
It's clearer, more
Simpler.
concise and direct, right?
Simpler and so, and I don't know, there are lots of ways to talk about this issue too, I think, in simpler ways. I think often I hear people say, every time I do a story, I get a bunch of letters and emails and calls from people saying, your climate has always been changing, right? Climate's always changing. And I say, well, yeah, the climate is changing, of course. But it's the pace of change. That's what it's about. That's the story. Climate, that's why I share the general's dissatisfaction with climate change. In fact, maybe this conference should come up with a better term. Global weirding, global racing, global whatever. But I think it's how we frame the discussion that I think is going to be really important moving forward.
Allison?
I wanted to add to that because the report that came out on Friday, it is your report. The audience for that report is you. It's the American public. It's all of us. And so if you're looking at this report and you're not understanding something, I urge you to say so. There's a public comment process that allows for that. And we do try our hardest to make it accessible to the public. But we, being scientists, we don't always know what makes sense and what doesn't. And so we could be learning from you and improving our communication with your help.
General Bolden, I want to ask you a question about the current state of climate change, because many people believe that while it was progressing at sort of, and I hate to use the word glacial pace, but moving along at this very measured pace, to where here in the last 5 years, we've seen some information that is disconcerting at best, where the temperature anomalies are really climbing to levels that we haven't seen before, that are what you would call pushing into that red zone. How fast do you believe that this is accelerating? And perhaps to some people, are we past the tipping point?
I'll defer to Allison for whether we're past the tipping point yet or not. We are close to exceeding the standard that scientists across the globe have picked as the level of temperature increase annually that we think is marginally acceptable. We're pretty close to exceeding that. The point I would try to make, though, from my layman's perspective as a climate scientist or climate lover, and wearing my Marine Corps hat, and Sherry Goodman, I think, is going to hopefully talk about this extensively tomorrow. All of us have family members, sons and daughters, or somebody that serves in the military. And, if you want them to have to do less of what we do today, you need to look at why we are in a lot of the places we're in. Frequently, it's not about greed. It's because people are hungry, or they don't have food, they don't have adequate water, and it's because the change in our climate has so accelerated that people just cannot get food to eat. Florida will see a gross degradation in their ability to produce vegetables and fruits and the like this year because of the violence of the hurricanes that went through and the amount of water. Texas will see a significant decrease in the amount of food products that they're able to take to market because of the excessive amounts of water in water events. You know, it's the severeness of the events that is occurring today that's the real problem. We're always going to have hurricanes. We're always going to have thunderstorms and the like. But we can no longer, we're getting to the point we just cannot tolerate the severity of the storms that come. So I think if you want your sons and daughters and friends to not have to go to some of these godforsaken places to try to bring peace again, or to separate people who are really battling over resources. And it's not always oil, it's frequently food and water. And that's something that hopefully Sherry Goodman will talk a little bit about tomorrow when she talks about the security perspective on changing climate.
Yeah, perhaps they're drawing that direct link between our troops in places like Somalia, Yemen, Niger. We'll continue that conversation tomorrow, but thank you for bringing that up. Dana, I want to ask you a question about talking to people, how this affects. Excuse me?
Question? I think a question.
Yes. General Motors, my name is Jack Stone. I thank you for your service. But a question, since you have seen the Earth from a unique perspective, 71% of our planet is water. Of that 71%, 97% is salt water, which leaves 3% fresh water. 2/3 of that are under the ice caps, which means for all of us, there's 1% of the water that is on this earth is available for our usage. I'm going to address answer my question to you. Agriculture consumes about 60 to 70% of that 1% of the fresh water that we produce. That is being challenged now as our population grows, as our concerns about feeding people increase. Where did you find answers to conflicts in terms of the amount of salt water of the 97% that you saw through the satellites? Where?
If I can draw, if I can, and you've got to help me here. You may remember one of the latter slides, the embedded video that I showed at the top it was soil moisture, and at the bottom it was salinity. As the global surface temperature increases, the amount of water evaporating from the ocean. So I won't talk about the percentages because I don't know. I take your data, your amounts as correct. It is going to get worse with increasing surface temperature. The amount of non-salt water in the oceans is going to decrease because as we evaporate water from the oceans, the salinity goes up. And that I made just a passing comment on that particular slide that said as temperatures rise, salinity begins to increase because there's less water, in a particular place than there used to be. When we get the sea levels beginning to rise because we're getting more water that cycles back, the compounding impact is that surface runoff, which has, and I won't go into this, but it has other things like nitrogen,
exactly from farming,
fertilizers, farming. So it is a very complex system that's all tied to our water cycle. So the problems get exacerbated rather than solved.
Well, when we're speaking about the ocean and you think about problems that we can't see, let me talk about the Great Barrier Reef off of Australia. And think about it as a huge underwater forest, right? How many people drive and see the leaves in the fall? Love those autumn leaves in the mountains. Let's just pretend like Nantahala National Forest disappeared, like it was stripped of all of its leaves and there were no more left. People would be wondering what the heck is going on. Well, if you look at the Great Barrier Reef of Australia, Dana, what's happening to that as we speak right now? It is a slow motion unfolding tragedy, is it not?
Well, the ocean, I think, to me, is the most disturbing aspect of this, and it is one reason is the least well known and understood. But the acidification of the ocean, the warming of the ocean, the double, triple whammy of coastal pollution, it's the degradation of the ocean, I think, has been dramatically faster than the degradation of land, and
it's what we can't see.
we can't see it, and we see the impact.
Yeah, can I take just? We keep saying what we can't see, and I've had the opportunity to see the planet from a little bit different
Some
perspective.
people have seen.
And I just want to inject what you see. And when I showed the Aral Sea, it is two areas that are perhaps the most photographed from space by us, by humans, because of the dramatic change in them is Lake Chad in Central Africa and the Aral Sea. And it's because what we saw was a slow degradation in those particular formerly very fertile regions of the world that all of a sudden, when I talk to my peers, people who live on the International Space Station and see the effect of climate change with decreasing lakes and rivers because of the increase in temperature and evaporation of water from the lakes and the like, it's speeding up. Our assessment is one that is qualitative. We don't have a way to, with our eyes, to give you a quantitative assessment of how much is evaporating. But subjectively, I can look and I can say from the time I flew my first mission in 1986 until the time I flew my last mission in 1994, the quantity of water leaving Lake Chad in Central Africa, the quantity of water evaporating from the Aral Sea was going up exponentially. It wasn't a straight line, and so that we can see from space. And if you talk to anybody who's been there, they will tell you that their major concern is the loss of vegetation in areas like the rainforests. Madagascar is completely devoid of, it used to be covered with mahogany and the like, and the mountaintops today are pretty barren. And that's a combination of climate change and what human beings have done to take away the vegetation that absorbs the carbon dioxide, gives us oxygen back and the like. So we are having the impact that we don't want to talk about, because, and my position has always been, everybody knows that the climate is changing. We can all agree on that. The question is, what impact are we as human beings have? If I say we are a part of the problem, I am morally obligated to do something about it. And that's my contention with the Congress today. Since I come from DC and I can now try to help, they understand what's happening. But if they admit that it's us, that it is we that are leading a lot, contributing to the cause, they're morally obligated to do something about it. So if you plead ignorance, you get away with it and you get to stay a little while.
Well, General, this is a personal question, but I have to ask it because you just don't meet too many people who've been in space. But does the Earth, and I've heard this from another astronaut saying, the Earth appears more delicate when you are up there.
Earth is pretty, it appears that way, but I just want, Earth is pretty resilient. Earth will be here. We won't. We depend, every one of us in here, I was infatuated with your, every other breath. When you look at Earth from space and you look at our atmosphere, it's a very thin blue line. Hopefully it's blue. Sometimes it's cruddy brown, where we really haven't been doing things. And you close one eye and you take your thumb and you put it up, looking out the window of the International Space Station, and you obliterate our atmosphere. When that goes away, we go away. Earth will still be here, as a system.
Well, let's not forget, we've been through violent
It will be
upheavals
devoid
before.
of us. So you think about it in terms of us. this is an impact on us as living beings and your kids and grandkids and the like. And that's what I worry about, is taking the planet to the point where it's here, but we no longer enjoy it because we're not here. That's the impact of the changing climate today.
Well, we have to end on that note. General Bolden, thank you so much. Tony, Dana, Allison. That just gives us the impetus to really want to be here, right? To make a change. We've got more great conversation coming your way tomorrow night. I hope you come back. We're going to hear from former Congressman Bob Inglis, who is very involved in this conversation. Sherry Goodman, the Undersecretary of Defense, who's advised the military for many years on the threats of climate change. South Miami Mayor Phil Stoddard and Beaufort Mayor Billy Kaiserman. We hope to see you back here tomorrow night at 7 o'clock. Thank you.